Reaction of ether with HI. Ether one, it is concentrate HI, another it is anhydrous. Let us see concentrate HI. It gives ROH plus R dash I. You see the mechanism with concentrate HI. This is 1 mole actually, not in excess. If nothing is given, in that case we have to do 1 mole. First protonation takes place. Now in second step, if any one of this alkyl it is 2 degree or 3 degree, then reaction proceed by SN1. If it is 1 degree alkyl group, or which do not gives the stabilized carbocation, it follows SN2. Suppose any one of these alkyl it is SN, that is 2 degree or 3 degree. In that case, it follows the SN1. And if R is more stable carbocation than R dash, if then this bond break. If suppose R dash is more stable carbocation than R, then this bond break, because formation of stable carbocation takes place in RDS step. This is next is RDS step. Finally, if there is any possibility for rearrangement in carbocation, then first this undergoes rearrangement. Next, I this attack, front or back, gives RI. See the example. Suppose this carbocation it is given. One side it is 3 degree alkyl, another side it is CS3. Reaction with HI, concentrate HI. Cold and concentrate. It is not, if nothing it is given, that is also self-assumed that HI is cold and concentrate. Now, because this is 3 degree alkyl which can give the stable carbocation, it breaks in such a manner so as more stable carbocation is formed. अगर ये सिग्मा बॉन्ड टूटेगा तो कार्बोकेटाइन 3 डिग्री बनेगा, ये सिग्मा बॉन्ड टूटा तो CS3 पॉजिटिव, तो इस 3 डिग्री कार्बोकेटाइन इज मोर स्टेबल. So carbocation, this carbocation it form minus CS3OH SN1, and this step is the rate determining step. Finally, I negative means nucleophile attack and it gives the product. So with concentrate HI, if any alkyl is 2 degree or 3 degree, it follows SN1. See next, suppose it is anhydrous HI. In case of anhydrous HI, suppose the compound it is given CS3 OCS2 CH3. In general, anhydrous Hi follow the SN2. But if any one of this alkyl it is 3 degree, in that case also it follow SN1. In case of 3 degree, SN1. In case of 1 degree and 2 degree, it follow SN2. So first it undergoes protonation. I negative attack from that side. Now SN2. I negative is as a nucleophile. In SN2 steric hindrance it matters. If it attack to this, it is more sterically crowded. If it attack to the CS3, this is less sterically crowded. So it attack to the CS3 and simultaneously this bond breaks and we obtain the CS3I plus CS3 CS2I. ये उस कार्बन पर अटैक करेगा जो कि लेस स्टेरिकली हिंडर्ड है. ये कार्बन CH3 वाला कार्बन लेस स्टेरिकली हिंडर्ड है, जबकि ये जो CH2 वाला कार्बन एक बल्की ग्रुप और 2 H से जुड़ा हुआ है. दिस इज रिलेटिवली मोर स्टेरिकली हिंडर्ड. दैट इज वाई I नेगेटिव ने उस कार्बन पर अटैक किया, इस न्यूक्लियोफाइल ने उस कार्बन पर अटैक किया जिससे कि ट्रांजिशन स्टेट लेस स्टेरिकली क्राउडेड बने, मोर स्टेबल बने और प्रोडक्ट में मिला CH3I एंड CH3 CH2I. इट इज SN2. If suppose the compound is, this is given, and reaction with concentrated Hi, Hi in excess, concentrated Hi in excess, if it is given in excess, and anhydrous Hi. Let us see in this case what exactly we obtain. हमें क्या मिलेगा प्रोडक्ट. Concentrated Hi 1 degree, this is 1 degree 2 degree, or we can say this 2 degree it is follow the SN1. Protonate it from the carbocation OHCH3 minus CH3 OH and carbocation we obtain CH3 now I it attack and it gives CH3 in case of excess. If Hi it is in excess, or heat either it is given or not given, in that case also, that is A, B, C. There are 3 reactions. Now we are discussing 3B. That is concentrated Hi. First it protonate and it gives bond breaking takes place, that is SN1. Trigonal planar, carbocation intermediate and CH3 OH. This carbocation it attack, either it attack to front or back, because it is not chiral, so it gives 2-iodopropane. Now this product again it react with Hi, because Hi it is in axis. This protonate it gives CS3, nucleophilate attack, it is SN2. So we are getting both as alcohol, iodide. This also we obtain as iodide, and these are the both part it convert into alkyl iodide if it is in axis. But if it is anhydrous, case 3, that is third reaction, compound is in that case, in case of anhydrous it is SN2. This iodide attack to less sterically hindered, and we obtain the product as CS3I. Reaction of alcohol with HX. This undergoes protonation, it gives OH. Now it is good leaving group. Previously it is poor leaving group. In presence of acid, it converts into relatively, that is better leaving group or good leaving group. Next, leaving group, it leaves the substrate. It forms the carbocation. If it gives the stable carbocation, if it is 2 degree, 3 degree, resonance stabilized, or if it gives the stable carbocation, it forms the carbocation, finally X negative attack. For example, compound it is given. Reaction with HBr. This undergoes protonation. Leaving group, it leaves the substrate. Now it is trigonal planar. Halide shifting takes place because rearrangement of carbocation now attack of Br, front or back, it gives two products. This is trigonal planar. It may attack to front, it may attack to back. So it gives the two products, means PHC Br CH3 R and S configurations. If you see the Lucas test, it is based on this reaction. Lucas test, it is used to distinguish 1 degree, 2 degree and 3 degree alcohol. In Lucas test, Lucas reagent is used. Lucas reagent is used. And what exactly is the Lucas reagent? That is, Lucas reagent is anhydrous ZnCl2 plus concentrate HCl. This is Lucas reagent. Anhydrous ZnCl2 and concentrate HCl. We can use this reaction, this test, to distinguish 1 degree alcohol, 2 degree alcohol and 3 degree alcohol. The Lucas reagent, this alcohol, 1 degree alcohol with Lucas reagent, it gives the turbidity converted to alkyl chloride after long time, that is, it takes long time for turbidity, that is approx 5 days. Long time for turbidity. That is approx 5 days. alcohol, it gives the turbidity after 5 minutes. When we introduce the Lucas reagent, it takes approx 5 minutes. Turbidity in 5 minutes. In 3-degree alcohol, immediate turbidity. If we see that reaction with 1-degree and 2-degree alcohol, it is SN2. SN2, it is anhydrous condition, and 3-degree it is SN1. Do you see the reaction? Mechanism with 1-degree and 2-degree, it is SN2, alcohol it protonate, HCl it is there, ROH, is attacked from back side. It gives RCl plus S2O. SN2. If it is 3-degree, in case of 1-degree and 2-degree alcohol, 1-degree or 2-degree alcohol, it is SN2. If it is 3-degree or if it gives resonance stabilized carbocation, the reaction is SN1. Are you getting or not? Yes? It's very important reaction. We can easily distinguish these alcohols on the basis of their turbidity. Actually, turbidity we obtain of alkyl halides. The turbidity it is due to this alkyl chloride. Formation of carbocation it is RDS, this is SN1. And now Cl it attack. If there is any possibility for rearrangement, it undergoes rearrangement, and finally we obtain RCl and turbidity of this alkyl chloride. This reaction it gives immediate turbidity, but in case of 2-degree it takes 5 minutes, and with 1-degree it is approx 5 days. 1-degree also can give the turbidity on heating. If suppose there is no turbidity, then heat the reaction mixture, it gives the turbidity either long time or it gives the turbidity on heating. If you see the problem based on this, compound it is given, how much time it will take for turbidity and which reaction mechanism it follow. I can say, suppose problems it is given. Find out the time for turbidity and mechanism for the following compound. Find out the time taken for turbidity and also mechanism with glucose reagent. Among following alcohols. There are some alcohols are given. This is given. See, in this case, this is 2 degree. It takes 5 minutes and reaction mechanism is SN2. This is 3 degree. It gives the turbidity immediate and reaction mechanism it is SN1. Now you tell me SN1 or SN2? This is SN2 and it takes long time for turbidity. Long time means approx 5 days or turbidity on heating. Either if you proceed this reaction it takes long time, or if you think that we want the turbidity and we can't wait up to 5 days, then what to do? Nothing. Simply heat the reaction mixture and you will get the turbidity of alkyl chloride. Next, this is the compound which cannot give SN1 as well as SN2. So this is the compound, no SN1, SN2 in that case. No reaction, no SN1, no SN2, so no turbidity. This compound also do not give the SN1, SN2, no SN1 because of Brett's rule, bridge added sp2 is unstable, carbocation will not form, and also SN2, no SN1, no SN2, so no turbidity. This is 2 degree, it takes 5 minutes and SN2. 1 degree, long time, SN2. 3 degree, immediate, SN1. 2 degree, 5 minutes, SN2 and CH3OH. Long time, SN2. If alcohol is resonance stabilized, in that case it follows SN1 and it gives the immediate turbidity. If alcohol gives the resonance stabilized carbocation. Come to the next. Next we'll continue on next day. Okay, thank you students. Have a nice day. Hello students, now we are going to start another one nucleophilic substitution reaction, SNI. Nucleophilic substitution intramolecular. Example, let us see Darton process. This is the reaction of alcohol with SOCl2. Gives product as RCl plus HCl, which is in gaseous in nature, which escape from the reaction mixture, and SO2. It also escape from reaction mixture due to its gaseous nature. If you see the reaction mechanism, this mechanism it is SNI. Alcohol react with SOCl2, it gives ROH as O negative Cl. It return the electron means it remove Cl negative, and this Cl negative it remove the H positive means in form of HCl it eliminates. Because HCl it is gaseous in nature, it escape from reaction mixture, and we obtain ROS double bond OCl. This reaction it is further, it gives RCl. It form 4-member cyclic transition state. This bond breaking, bond formation, bond breaking. This is 4-MCTS, 4-membered cyclic transition state. 4-MCTS means 4-member cyclic transition state. Finally, this is bond breaking, bond formation, bond breaking, bond formation. It gives RCl as product plus SOCl2, which escape from the reaction mixture due to gaseous in nature. Important thing in this reaction, first, this reaction it is, we see that stereochemistry of this reaction, that is Darjan process or SNI reaction. Retention of configuration takes place. Suppose this R it contain the chiral center or chiral carbon. In that case, this chiral carbon, if it is S in configuration, in product also we obtain the S configuration, because here it is attack from same side. Attack takes place and leaving group leave. Therefore, retention of configuration takes place. There is no change. If we see that SN1, racemization takes place. In SN2, inversion of, that is Walden inversion takes place. If we see the stereochemistry of SNI, retention of configuration takes place. R remains RS, configuration of that particular chiral carbon remain S. If we see the characteristics of reaction, first, Darjan process is good process to obtain. It is good process. Darjan process is good process to obtain RCl from alcohol, alkyl chloride from alcohol. Because that is side products, they escape from reaction mixture due to their gaseous nature. Because side products, what are the side products? Tell me. Side products are HCl and SO2. Side products, that is HCl and SO2, escape from reaction mixture due to their gaseous in nature. Due to their gaseous in nature. अगर ये OH कायरल कार्बन से अटैच्ड है और उसकी कॉन्फ़िगरेशन R है, तो प्रोडक्ट में R सेल की भी कॉन्फ़िगरेशन R कॉन्फ़िगरेशन रहेगी। अगर ये S कॉन्फ़िगरेशन है तो प्रोडक्ट में भी S कॉन्फ़िगरेशन रहेगी। सो लेट अस सी दिस वन। सेकेंड कैरेक्टरिस्टिक, retention of configuration takes place. Retention of configuration takes place because reaction proceed via cyclic transition state. That is, R remains R, R configuration, and S remains S configuration. Because reaction proceed via cyclic transition state. Attack same side attack and leaving group leave from the same side. Because reaction proceed via cyclic transition state. Reaction proceed via cyclic transition state. But this reaction, if we proceed in presence of pyridine if it is there, in that case reaction proceed via SN2. Let us see next. And the driving force in this reaction, it is the formation of SO2, that is higher energy of SO2. This is the driving force which proceeds the reaction in forward direction, formation of S double bond O. If we see the third point, that is if the same reaction it is achieved by in presence of pyridine, then reaction proceed via SN2 reaction mechanism and Walden inversion takes place. That is, if reaction is done, or if reaction is proceed in presence of pyridine, in presence of pyridine or pyridine, then it converted into SN2 reaction mechanism. Then it follow SN2 reaction mechanism. It follow SN2 reaction mechanism. And Walden inversion takes place. That is, Walden inversion takes place. You see the reaction. Example. If you see the example, here the compound it is given, that is CH3 DH and OH. So the reaction proceed in presence of SOCl2 only, that is reaction with SOCl2. Then retention of configuration takes place. On the other hand, the similar reaction it is done with SOCl2 in presence of pyridine. This is pyridine, which acts as a base. Then reaction proceeding via SN2. Why it is SN2? Why it is SNI? In SN2, Walden inversion of configuration, Walden inversion takes place. It is product to be obtained, and major product in this case it is Cl, CH3, DNH. As a product it is Cl, H, D and CH3. Let us see the mechanism. Why we are just getting this type of product? This is by SN2, this is by SNI. Let us see the reason. If it is A, this reaction it is B. With A, mechanism, it react with SOCl2. Similar mechanism SNI, it gives next it remove the Cl, it remove HCl, we obtain CH3, H, D, O, S, via 4-MCTS, it attack and it remove the HCl, that is SO2, and it gives the product via 4-membered cyclic transition state. It gives Cl plus SO2. If you observe the configuration, here it is 1, 2, 3, R configuration. There also, because this is as a first priority and OH also it is first priority, 1, 2, 3. 1, 2, 3, R configuration. In substrate it is same configuration and product also it is same configuration. So overall we can say that retention of configuration takes place because attack it is from same side, it is not from back side. But if we use the pyridine, in such case what exactly we obtain the product? Let us see the second mechanism is B. In that case Walden inversion takes place and reaction mechanism converted from SNI to SN2, it is not SNI in that case. If pyridine it is used. Suppose similar reaction if it is proceed in presence of pyridine. Previously it was A, now it is B. Mechanism of B. Reaction start in similar manner. That is CH3HD. Reaction with SO2, SOCl2. Attack. It pick up the electron. We obtain CH3, H, D, OH, S, Cl, O negative, Cl. Similar intermediate we obtain. Next step, it remove the Cl. Also it remove in form of HCl, but this HCl which it remove, it react with pyridine which is present in our reaction mixture. So immediate acid base reaction takes place. This is as acid, pyridine it is as a base. It gives pyridinium chloride. So it is not escape out. If it is not escape out from the reaction mixture, it gives pyridinium chloride. Previously what happened exactly? Previously there was no base was present and HCl which removed, it escape out because it is gaseous in nature. But here it is because of the presence of pyridine, it reacts with pyridine and it gives pyridinium chloride. Now let us see this compound. There are two possibilities. One possibility, it attack and it remove like SNI. Another possibility, because anionic Cl negative, it is present. It may attack from backside and it remove. Another thing is nucleophilicity. If we see Cl, neutral Cl, it is less nucleophilic than that of negatively charged. You can also observe this is having somewhat positive charge due to resonance. The lone pair of Cl, it is undergoing resonance. So nucleophilicity or negatively charged is more nucleophilic. Another point it is why it is converting into SN2. If it follow the SNI, it is via 4M CTS, which has somewhat angle strain. Therefore, now attack, it is more nucleophilic, backside attack takes place, it remove in form of SOCl2 and again this is SN2 and the product is, it gives via SN2 backside attack it is there because negatively charged Cl, it is more nucleophilic rather than this. So it do not follow the SNI, major product we obtain via SN2 and Walden inversion takes place. There we obtain inverted product. Again pyridinium chloride. The Cl. So in presence of pyridine, reaction converted into SN2. So this is the major product in that case. Let us see next.